Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq AIMAN bin KAMARUDIN. My group members name is Muhammad AMIRUL and Muhammad ZAKI. Today, we would like to present about application of differentiation and integration. Do you guys know definition of differentiation and definition of integration? Definition of differentiation is the essence of calculus is derivative. The derivative is the instantaneous rate of change of the function with respect to one of its variables. This is equivalent to finding the slope of the tangent line to the function at the point. Then we go to the next slide. Definition of integration. Integration is a way of adding slice to finding the whole. Integration is often introduced as a reverse process to differentiation and has wide application. Then, when to use differentiation? We use differentiation to determine the maximum and minimum value of particular function. For the example, first, cost. An accountant use differentiation to find the company their company profit. Then we use differentiation to find the strength. Lastly, civil engineer use differentiation to find amount of the material used in the building. Derivatives are met in many engineering and science problems, especially when modeling the behavior of moving objects.
When to use integrations? We can use integrations to find area, volume, selling point, and many useful things. But it is easiest to start with finding the area under the curve of a function. We can see the example below. The example shows that the curve of a function. We can find the area, volume, or central point by using integrations. So we move to the next slide. A problem statement. In problem statement, we can see that we can know how to calculate the amount or dose of medicines that can be put into the capsules. Besides that, we also can find the profit from selling a bottle of medicine to the buyers, such as a hospital or the others buyers.
So this is our capsule. A capsule in the form of a cylinder of length t cm with hemisphere of radius r cm at the two ends is shown below. The surface area of the capsule is 2 cm squared. For the problem solution, A. Show that the volume of the capsule is given by V equal to R minus 2 per 3 pi r squared, pi r cubed, sorry. We know H equal to T and R equal to R. So we go to the next slide. Surface area capsule equal to 2 cm squared. So surface area equal to 2 pi r h plus 4 pi r squared equal to 2. So we change h to t. It will be 2 pi r t plus 4 pi r squared equal to 2. So the answer is t equal to 1 minus 2 pi r squared per pi r. Okay, then to find the volume of a capsule, V equal to 2 per 3 pi r cube plus pi r square h. So we change h to t, so it will be 2 per 3 pi r cube plus pi r square bracket t. So when we solve it, it will be 4 per 3 pi r3 pi r power of 3 plus pi r squared bracket 1 minus 2 pi r squared per pi r. So the answer is V equal to r minus 2 per 3 pi r cube.
Find the value of r so that the volume of capsule is maximum. Firstly, we have to find S limit, which is dV over dr equal to 0. We use volume formula, which is r minus 2 over 3 pi r cube. From that equations, we differentiate become 1 minus 2 pi r cube. We find the value of r, which is 0.399. We also have to use a second derivative test to make sure that the value that we find is a maximum value, the maximum volume of capsule being filled. So we differentiate again the equation, which is 1 minus 2 pi r cube. From the equation, we differentiate and get the negative 4 pi r. We substitute the value of r 0.399 into the second derivative equations, negative 4 pi times 0.399, and then we got a negative value. The negative value shows that we got a maximum volume of capsule.
When we got r equal to 0.399, we must put the value of r in this equation. The equation is r minus 2 over 3 by r power of 3. So when we put the value of r in this equation, the maximum volume of the capsule is equal to 0.2666. Let's move to the next question. The demand for an item produced by Merchant Berhad is given by P plus 0.2x equal to 100, where P is the price per unit bottle of medicine and X is the quantity demanded. The total cost Cx producing X units of the items is given by Cx equal to 800 plus 30x, where X is the level of output. Okay, the formula for total revenue is price multiplied quantity. So Rx equal to Px multiplied X. So the total profit equal to total revenue minus total cost. So pi x equal to Rx minus Cx. So the Cx equal to fixed cost plus variable cost. Okay, A. The total profit when 100 bottles are sold. Okay, first we must find the total revenue function. Total revenue function equation is Rx equal to Ps multiplied X. So 100 minus 0.2x multiplied X. So the answer for total revenue function is 100x minus 0.2x squared. Okay, next we are going to find a total profit function. Total profit function is pi x equal to Rx minus Cx. So we put the value of Rx and Cx in this equation. So the total profit function is equal to negative 0.2 squared plus 70x minus 800. Okay. When we got a total profit function, we must replace x with 100. It is because we are going to find the profit when 100 bottles are sold. Okay. We put the value of 100 in this equation. So the total profit when 100 bottles are sold is equal to 4,200 ringgit.
So next question is the marginal profit function. We use marginal function to find the profit. So to find marginal function, we must to differentiate the profit function. So it will be d per dx bracket 2 0.2x square plus 70x minus 800. It will be negative 0.4x plus 70. So we get a marginal profit function.
Find the marginal profit when 90 and 300 units are sold. Firstly, we have to use a total profit equations. From the total profit equation, we have to differentiate it. So firstly, we substitute the 90 into the x inside the equations. So we got the 34 ringgit in the 90 units bottle medicines are sold. We can define that when 90 units medicine bottle are sold, the profit will increase 34 ringgit per unit of the products. So the second one, we substitute 300, the value of 300 into the x inside the equations. So we got a negative value, which is 50 ringgit. We can define that when 300 units are sold, the profit will decrease Rm 50 ringgit per unit of the product. So from that questions, we can see that as the number of medicine bottles so increase, the profit decrease. It is because the larger the number of product manufacturers, the larger the cost.
Guys, I'm going to tell you about the conclusion. Okay, the conclusion can we get from this topic is we can calculate the amount of medicine that can be put in the capsule by using integration and differentiation. Next, can make sure that to consume enough dose for patient. Next, we also can calculate the profit of a bottle that being sold. Okay, the last conclusion is differentiation and integration can help us solve many types of real world problems. We use the derivative to determine the maximum and minimum value of particular functions. Okay, that's all from us.